Welcome to RustyPipes. This is a new project. It's a virtual pipe organ. It loads sample sets that contain recordings of individual pipes from organs, and it plays it back, controlled by a MIDI, your traditional computer keyboard, whatever you like. This is the configuration screen. This is what you see when you start the program. When you first load in, the first thing you want to do is load an organ file. So there is various sources of files on the internet. There's some paid ones. RustyPipes supports Grand.org and Hauptwerk. Notably, for Hauptwerk, it only supports unencrypted files. Also, Hauptwerk support is still a bit of a work in progress, so keep that in mind. Grand.org sample sets should work. Most of them work really well. I like to use Friesach. Friesach is one of the bigger, nicer organs that is free. But there are other ones, of course, and not every organ has to be super large. You select your audio device on Linux. Normally it's like the default is fine. 48 kilohertz sampling rate, whatever your interface supports will be available here. Then you have your MIDI inputs. You can of course run without any MIDI input. You can just play with your computer keyboard. Of course you can't play a lot. So I have two devices here. I'm just gonna select both. And then you have this map button here, and that allows you to map the MIDI device and its channels to what is virtual channels within RustyPipes. So RustyPipes internally has 16 channels that you can assign to any number of stops of the organ. So the organ has essentially a lot of pipes. There's groups of pipes that belong to one sound, and these pipes are collected in essentially a stop. This is a simplification, of course, but this is all you need to know at this point in time. Since RustyPipes has 16 channels internally, that doesn't work if you have multiple MIDI devices. So obviously you have to somehow map it. The way you do this is, for example, if I have two different keyboards here, I can go in here and click map for this for these Lumi keys, and I have two options. I can select simple mode or complex. Simple is what it says on the tin. You take any event from that device, regardless which channel, doesn't matter, and it puts it into one channel in RustyPipes. So the way you would do this in real life, if you had like one keyboard as the first manual for your organ and a second keyboard as the second manual, and then maybe you have pedals as another device, you can just map, for example, the first manual channel 1, click done, the second manual to channel 2, click done, and then the pedals you could map to channel 3 or something like that. If you have a MIDI interface and you have multiple MIDI devices connected to that single MIDI interface, and that MIDI interface appears here, you can do complex mapping. That means MIDI channel 1 could be the internal channel 1, or it could be channel 2 or whatever. So you can do this for any MIDI device. You can have multiple MIDI devices, create MIDI events on one virtual channel inside RustyPipes, whatever you like. So let's just keep it simple here. That was the LPK, that's channel 2, and that's channel 1. Okay, fine. You can play a MIDI file. If you do this, you cannot play with a MIDI controller. This is nice if you want to play back somebody else's performances, of course. You can select the reverb. These files need to be in a reverb folder in your configuration directory. You can select the reverb mixing. Just keep it low here. You can set the gain. You can set the polyphony. Depending on your CPU, you can set this higher or lower. With a good CPU, you can go like 500, 600. If you run into troubles, you might want to lower this. You can lower and raise this while you're playing, so you don't need to experiment here. You can do this while playing. Audio buffer size, this is something that you need to set according to your system performance. If you want to play it safe, set it to 512 or something like that. If you have a better computer, you can set this to a lower number. And then we have the preload buffer. That's a bit more complicated. The way this works is the samples of the organ will be streamed from disk, unless you enable pre-caching. Then they are just loaded into RAM. But in order to minimize latency, what happens is we load the beginning of every sample into RAM. So instead of, like, if you have a 60 gigabyte sample set, this loads only the first 64,000 audio frames, so stereo samples essentially, into memory. So instead of loading 64 gigabytes of sample data into memory, it just loads like 1 gigabyte. If you have more RAM, you can raise this number. If you have less RAM, you can lower it. With 32 gigs of RAM and this kind of setting, it's usually fine. It also depends on the size of the organ. So if you have many stops, if you have like 100 stops, you might need to lower this. So this is something that you can play with. The consequence is the beginning of each sample will be in RAM, so the sample will start playing immediately, and then the rest of the sample will be loaded from disk while the beginning is playing. So essentially this gives you the best of both worlds of completely pre-caching everything. It also speeds up loading times because, as you'll see, it'll be much quicker. Convert to 16-bit. You can have every sample be converted to 16-bit. I wouldn't do this. It's not really necessary. Just leave it at 24 bits or whatever the original sample rate is. Use original tuning. That's a weird one. Organ sample sets usually have some tuning information to make the tuning perfect. And this setting disables this tuning process if the tuning is off by just a little bit. So if the tuning is off key by less than 20 cents, so 50 cents is like a half tone, 100 cents is a whole. If it's less than 20, it'll not do the tuning. If it's more than 20, it will do the tuning. The consequence is some sample sets have like a special kind of sound if they are slightly detuned as they were at recording. So you can enable that, or you can disable it, which means just use all the tuning information that's inside the sample set, which usually means the tuning is perfect. Or almost perfect. Okay, so let's click start. It will load and convert any sample files as necessary, and then we are on the main interface. And this might look a bit messy. The user interface is also a work in progress. But essentially you have all your stops here. And for each stop, you have buttons for each of the 16 internal channels. So what happens is, if I have a keyboard here that's on channel 2, and I play some notes, I hear nothing. What I have to do is, I have to press 2, because this is channel 2 here, and then I hear something. If I press channel 1, I hear nothing. I need to use the other keyboard. Of course, you don't want to be clicking around all the time here. The idea is that you have some sort of presets. Usually this is done via what's called switches, but I have not implemented switches yet. And also this depends really on the organ, and you might want to be more flexible. So the more flexible thing is to do any settings that you like and then press, for example, Shift F1. And if you want to recall it, you just press the function key. So I have here one preset, which is quite quiet. Then a slightly louder one, or you can have tutti. You can have tremulant, which is also a work in progress. So this might not sound perfect yet. Feedback is very welcome. You can do all these shortcuts via these buttons. You can also control this via a REST API. I'll show you that later. Here you can change the reverb while you're playing. You can change the mix while playing. You can change the gain, and you can tune up and down the polyphony. Polyphony doesn't prevent voices from playing. What it will do is any voices that are above the polyphony count will essentially fade out really quickly. The end effect is that the maximum amount of voices will basically be assured to play fully and have the full tail of the release sample being played. But any sample that goes over this, the oldest ones at least, the ones that have been playing for longest, will fade out really quickly. So like within a second. So you might actually see more voices here than the maximum. So you'll have to play with that a little bit. The API is just on port 8080. You can just visit that with a web browser, and you can really do whatever you can do in the main user interface. You can do via this API. So you can get like the available tremolence, and then you can set the tremolence, or we could try preset, for example. We could say load preset. Let's load preset number 10, and that should give us, yeah, everything. If we say number 1, it loads preset number 1. Also, you'll see here there is like recording, audio, and MIDI. These functions you can enable via these buttons down there. If you press record MIDI, your MIDI performance will be recorded into a file. And if you press record wave, then your actual sound will be recorded into a file. There is also a mode that uses the terminal that has all the same functions. So also MIDI devices you can configure here. You can say simple mode, complex mode. It's all in text mode. You can change the reverb, and you can press start, and then it will load the organ, and then there you go. And that's it. Now you can use the cursor keys, and you can set the channel presets. In the text mode, it only goes up to 10 because it's using the number keys, but of course you can use the REST API to do all that. Another thing, you can actually control the stops via MIDI commands. The way you do this is in text mode, you press I. So for example, if I said I want to have Spitzflöte 4, I want to enable and disable a stop via MIDI command, because right now it's disabled. Press I, and I can select, I can clear this, for example. I can say the enable event should be when I press this note on event. So I press enter, listen, and when I release the note, it should be disabled. So I need to hold it and then release it. What will happen now is, you see Spitzflöte is active while the note is on, and deactivated when the note is off. We can of course also do this in the graphical mode. Same principle. You get there by just clicking on the name of the stop. So I can do this, or I can disable it with another note on. Example, yeah. So now, and you see there's another one because I played around here. If I remove that, then it's just that one. So you can really go to town here. You can have MIDI input devices that send events that essentially act like the drawbars, like the stop pulling on an actual organ. And that's it. That's RustyPipes. There is sound samples on the website, on GitHub. Any feedback is welcome. I do not plan to support encrypted Hauptwerk sample sets. I actually don't really have any plans to support like a graphical representation of the organ or loading that from the files. And I probably will not support switches as they are defined inside these organ sets, but it's open source. You know, if somebody wants to implement something like that, feel free to. This is currently version 1.1.0 with some extras because the API, the REST API, is coming in the next version. Patches are welcome. Let me know what you think. thanks for watching and thanks for listening.